Hey viewers, welcome to all. Here we are discuss about the project. A highly efficient conditional feed through pulsed flip-flop for high-speed applications. In recent digital applications will require highly efficient and high-speed gadgets, it's related to minimum delay and power consumptions. Thus, this proposed work of this paper will present a novel type of conditional feed through pulse-triggered flip-flop. The data output of this pulse-triggered flip-flop was highly optimized using pre-discharging and conditional signal feed-through schemes. And the power consumption also reduced using shared pulse generator. This proposed work will compare this pulse-triggered flip-flop to 7 different conventional topology flip-flops at 16 nanometer CMOS technology and such as transmission gate flip-flop, modified hybrid latch flip-flop, static latch conditional discharge flip-flop, conditional pulse enhancement pulse-triggered flip-flop, signal feed-through pulse-triggered flip-flop, conditional data mapping pulse-triggered flip-flop. Hence, the proposed work to reduce the number of transistor in feed-through pulse-triggered flip-flop improved the performance of delay reduction in proposed pulse-trigger flip-flops. This work was developed in Tannerata tool at 65 nanometer CMOS technology. Now we can verify this base paper. Figure 1 will show transmission gate flip-flop and Figure 2 will show conventional pulse-triggered flip-flop. It's having 5 options. Option A will be shown modified hybrid latch flip-flop. Option B will be shown static latch conditional discharge flip-flop. Option C will be shown conditional pulse enhancement pulse-triggered flip-flop. Option D will be shown signal feed-through pulse-triggered flip-flop. Option E will be shown conditional data mapping pulse-triggered flip-flop. And the figure 4 will show the proposed work of pulse-triggered flip-flop. Now we can verify the Tannerata output. First, this is the transmission gate flip-flop test bench design. And this is the transmission gate flip-flop circuit design. And this is the transmission gate flip-flop simulation output. And second, this is the modified hybrid latch flip-flop test bench design. And this is the modified hybrid latch flip-flop circuit design. And this is the modified hybrid latch flip-flop simulation output. And third, this is the static latch conditional discharge flip-flop test bench design. And this is the static latch conditional discharge flip-flop circuit design. And this is the static latch conditional discharge flip-flop simulation output. Fourth, this is the conditional pulse enhancement pulse-triggered flip-flop test bench design. And this is the conditional pulse enhancement pulse-triggered flip-flop circuit design. And this is the conditional pulse enhancement pulse-triggered flip-flop simulation output. And fifth, this is the signal feed-through pulse-triggered flip-flop test bench design. And this is the signal feed-through pulse-triggered flip-flop circuit design. And this is the signal feed-through pulse-triggered flip-flop simulation output. And sixth, this is the conditional data mapping pulse-triggered flip-flop test bench design. And this is the conditional data mapping pulse-triggered flip-flop circuit design. And this is the conditional data mapping pulse-triggered flip-flop simulation output. Seventh, this is the proposed work of pulse-triggered flip-flop test bench design. This is the proposed work of pulse-triggered flip-flop circuit design. And this is the proposed work of pulse-triggered flip-flop simulation output. After this, all this output parameters will be taken and put in the comparisons document here. Here can compared number of transistors, area, power, and delay. Here, proposed work delay will be reduced. This is the proposed work delay report. After this, we are written abstract document for this project. Base paper abstract. Enhancement of this project. Proposed title. Proposed abstract. Existing system. Disadvantages. Proposed system and related notes for proposed work. Advantages. Literature survey. Finally, reference. Thank you to spend your valuable time for this project explanation.
If you need more video related with VLSI projects implementation, please like and subscribe this channel.